Hi guys, welcome back to Chemistry 24/7 series. In this series, we have been exploring the solution for previous year exam papers. If you are new to this channel, don't forget to subscribe to get more engaging content like this. So let's see what is today's problem. So this is the problem from University of Hyderabad 2022 biggest entrance exam question. So according to this question, here you see this substrate initially react with LDA, which then react with this alkyl halide. Then finally, when you treat with methyl iodide in hydrochloric acid, which produce the product. Here you see there are the four options. Let's find out together which one is the correct option. The first step, which involving LDA. So LDA we already discussed a lot in our channel. If you missed to watch, don't worry, you can find a link from our description box. LDA is one of the non-nucleophilic sterically hindered strong base which readily affect the protons from less hindered side. When you come to the our substrate, here you see this side has two acidic protons. Therefore, when you use LDA, which readily abstract one of the proton to produce this corresponding aza unilate ion. In order to understand this reaction diisopropylamide, so first we should draw the transition state model. So this transition state model helps us to visualize how this reaction occurs by diisopropylamide. So before moving that, so particularly this part is called SAMP. So SAMP means that, so S indicates that configuration of this center, and AMP stands for amino-methoxypyrrolidine. So this chiral auxiliary widely useful for the generation of chiral compounds. So now you see we should draw the transition state model. So before moving that, so you should label this hydrogen as R1 while that methyl as R2. So this is the transition state model. So here you should note the 2 points. First point, this double bond should be present in E configuration. So how it E configuration? Here you see this R2. Here is methyl, while this part is present in the transphation. Therefore, this configuration is E. And next, another point is this carbon nitrogen bond should be present in Z configuration. How it Z configuration? So when you move this electron here, you will get the double bond here. So now you see, so this part, this bulky part as well as this part also present in the same phase, I mean same direction. So therefore this one present in the Z configuration. Next to come to this structure, this nitrogen-nitrogen bond is rotatable. So if you rotate this nitrogen-nitrogen bond, so you will get the structure like this. It means that this particular center configuration doesn't change. So now you see this CH2OMe group, this oxygen coordinate with this lithium, and simultaneously two solvent molecule also coordinate with lithium. So this is the transition state model for this alkylation reaction. So now you closely look. So this portion present in the plane. So now you consider the top face is highly sterically crowded while the bottom face is less sterically crowded. Therefore, when you use this alkyl iodide, so that may not approach by top face since top face is sterically crowded while the bottom face is free. Therefore, so this alkyl halide approach this aza-unilate ion by bottom face. So now you see what happened. This electron shifted again and followed by this electron attack this carbon and followed by kick off I minus to produce this corresponding intermediate. So now you see this alkyl path present at the bottom face. That means that so this alkyl halide approach this inlet ion by bottom phase to produce this intermediate. So for our convenience, we can redraw this intermediate like this. So when you do this carbon-carbon rotation, you will get this form. So up to this level, this reaction is called Kenter-SAMP alkylation. So next step is the reaction of methyl iodide with HCl. So now you see this substrate. For our convenience, we can mention this alkyl path as R. So when you react with methyl iodide, so here you see, so this nitrogen, tertiary nitrogen as well as imine nitrogen, both are reactive against methyl iodide. Therefore, you will get the corresponding methylated product as a mixture. So in the next step, when you do the acid hydrolysis, which readily this imine bond cleaved to produce this corresponding aldehyde along with this amine byproduct. So when you do the basic workup, so particularly this compound going to the aqueous phase, while this compound going to the organic phase due to the neutralization. So after that, which readily undergo oxidation under air to produce this intermediate. So in this intermediate, under this reaction condition, readily lost the formaldehyde as a byproduct that produce this SAMP chiral auxiliary. This is one of the way partially recycle the SAMP chiral auxiliary. So based on our discussion, so here you see the option A is the correct option for this question. That's it for today's problem. And don't forget to like, share, and subscribe for more engaging content like this. And finally, thanks for watching and see you next time. Bye bye.